You type a sentence into ChatGPT, and it responds with something that actually makes sense. But how? How does a machine figure out that when you say the cat sat on the mat because it was tired, the word it refers to the cat, not the mat? The answer is one word: attention. In 2017, 8 Google engineers published a 15-page paper called "Attention is All You Need." Just 15 pages. And from those 15 pages came ChatGPT, Gemini, Llama, Mistral, literally every major AI model you use today. The architecture they introduced, the transformer. So what's the core idea? It's called self-attention. Once the model has broken your text into tokens, which we covered in episode 1, every single token looks at every other token and asks one question: how relevant are you to me? Let's go back to our example. The model looks at the token IT, compares it with every other token, and computes an attention score for each pair. IT and cat, high score, strongly related. IT and mat, low score. IT and tired, also high. That's self-attention doing its job. But how does the model actually compute those scores? Here's the trick. Every token gets converted into 3 vectors: a query, what am I looking for; a key, what do I contain; and a value, what's my actual information. Think of it like a search engine inside the model's brain. Step 1, take the query of one token and dot product it with the key of every other token. The dot product measures how similar 2 vectors are. If they point in the same direction, high score, these tokens are related. Step 2, scale. Divide all scores by the square root of the dimension to keep numbers stable during training. Step 3, convert those raw scores into probabilities that add up to 1. Now you know exactly how much attention each token deserves. Step 4, the magic step. Multiply each token's value vector by its attention weight, then sum them all up. After this, the token it doesn't just mean it anymore, it now carries the meaning of the cat being tired. It has absorbed context from the entire sentence. But real transformers don't run attention just once. They run it multiple times in parallel, called attention heads. Why? Because one head might learn grammar, another learns that it refers to cat, another learns word proximity. Multiple perspectives all at once. Now here's why transformers killed the old approach. Before transformers, we had RNNs that processed tokens one at a time, left to right. By token 1000, they'd nearly forgotten token 1. Transformers process all tokens simultaneously. That's why they're so fast and so powerful. The full transformer architecture stacks 2 operations in each layer: self-attention, then a feed-forward network. These layers repeat dozens or even hundreds of times. GPT-4 has around 120 layers. Each layer builds deeper understanding, from grammar to meaning to reasoning. And here's the practical takeaway. Self-attention has O of n squared complexity, double your tokens, quadruple the compute. That's why there's a context window limit. And because transformers see all tokens at once, the order of your prompt matters less than you'd think. Keep that in mind next time you're prompting. So to recap, one 15-page paper gave us self-attention, multi-head attention, and the transformer architecture, the engine behind every major AI model. If you found this helpful, hit subscribe, because next episode we're tackling parameters. What does it actually mean when someone says a 70 billion parameter model?